Okay, this is the last calculus question in the November 2020 exam, and it's a min-max problem about a rectangular box that has to be constructed. There's length, there's width, and there's height, and the length of the base has to be 3 times the width. The volume is 5 cubic meters. The material for the top of this box costs 15 Rand, and the material for the four sides costs 6 Rand per square meter. Show that the cost to construct the box is really 90 W squared plus 48 WH. Well, the first thing you do is you need to make a picture. So you make a picture like this. Make a rectangular box. Well, there's the width. Let's call that W. The length has to be 3W. And there's H. Okay? Now, if we're working out the cost, what we need to work out is we need to work out the different parts. Like, let's just, well, I'll just do it. Doesn't really matter what order you do it in, but let's think of the bottom and the top. Well, the area is 3W times W. That's 3W squared. There's a top and a bottom. That's why we need to multiply by 2. That will give us the area in square meters, and we have to multiply that by 15 to get the cost, 15 Rand per square meter. Well, there it is. 3 times 2 is 6 times 15 gives me 90 W squared. Well, that explains that part. But now there's a front and a back, which would be 3WH, and the, the right side and the left side, which would be W times H. So 3WH plus WH is 4WH times 2, because there's left side and right side and a front and a back, and then times 6 because that's its cost. Well, 2 times 3, oh, 3 plus 1 is going to give me 4WH times 2 times 6 gives me 48WH. Well, that explains the formula for the cost. Now they're going to ask us to minimize what the width that will minimize the cost. So let's see what that will look like. Okay, the first thing, well, maybe I'll get rid of all of this stuff here. I should have done maybe this over on the other side. I need to figure out H. I need to figure out H in terms of W. Well, the volume equals the width times the length times the height. So I can do that. And then I just divide by 3W squared and I get what H is. Now, in this formula for cost, we can write it all in terms of W, and you have to do that all in terms of one variable. So instead of H, we rub it out and put 5 over 3W squared. Now we multiply this out. 48 divided by 3 times 5, it's 80. And W over W squared is W to the minus 1. 1 over W, W to the minus 1. Well, there's the function for cost in terms of just W. Now, if we want to find out where it's going to be maximum, the W that's going to give us maximum, we find the derivative and we let it equal 0. That'll give us a local minimum or maximum. They said, what's going to make it minimum? So we take this derivative and let's see what we go. That's 180, the derivative of, oh, sorry. Here we go. 2 times 90 is 180W. Okay, there you go. But if I multiply this, negative 1 times 80, that's minus 80, and I bring it down 1, it's negative 2 there. Okay, now that negative 2 is really over W squared. We're going to make this derivative equal to 0 to find the minimum. We're going to make it equal to 0 to find the minimum. That's what you have to do. But this W squared is really in the bottom. What they do is they multiply everything by W squared. W squared times the W to the minus 2 cancels, and that's why there's an 80 there. W squared times W gives me W cubed. And then there's just 0 here because you want to find out the minimum is going to happen when the gradient is 0. Well, now all we do is add 80, divide by 180, and take the cubed root. That'll give me W cubed. Take the cubed root, and we get our answer of 0.76 meters. They should put the units, they forgot in the memo. 0.76 meters. That's the answer for the width of the box that's going to minimize the cost. You see, this was the cost function, finding the derivative and then making it equal to zero. We can find the top or bottom of the curve, and that's why it's giving us a minimum. And that's how it works.